Welcome everyone after a really long break to another Draco compiler development session. It's been quite a while, so to get back in the saddle, we're going to start off with a really simple feature. At least I hope it's simple. As you can see, I made a little header comment here. Basically, what we're trying to do is get default values like you have in C#, null, and basically default T for any type in C#, but have it in Draco as well. And the way we're going to have it is that we're going to have an intrinsic function, basically a function that the compiler knows inherently without us needing to define its source code anywhere, and the compiler would know how to basically generate the appropriate code to fill in that value with the default. So basically we would use it like so. And you would pass in some type here like object. And this would basically give you null. But if we pass in a value type, like maybe system.hashcode, it would give us a zero initialized instance of that struct. So we could also have something like so. And this would be this in C#. Man, Copilot is sometimes really awesome at completing these. Now, as you can see, our tooling is really not happy about this. It's not surprising. These are not defined yet. Now, question might be, what would the type of these be? For now, this will stay an object, and the below would stay as system.hashcode. In the future, we might try wrapping nullable ref types into an option or something like F# tries, I believe. But we will cross that bridge when we get there. There are a lot of ugly things that we would need to solve with nullable ref types. So for now, we're just going to ignore that. The reason we even started to work on this is because I've been looking at the CLI for the compiler. Let me actually bring that up here real quick. And I've been thinking of porting it to Draco, so we would have our first, self-hosted component of the compiler. At least the CLI could be written all in Draco. And I've noticed a lot of things, small things we are missing. One of which is being able to just type out null or something. So why not start with this? Now, for me, the default as a method came from the idea that we already did arrays as intrinsic generic types. But it turns out that we are not the first to do this, even in .NET. F# has the unchecked module, and within the unchecked module, you can see that they have a method called default off, which basically does what you would think. It returns the default value. And I believe this is an intrinsic, but let's quickly check their source code for it. So it calls unsafe default. And yeah, to me, this looks like some inline IL that we don't do. But basically looks like an intrinsic to me. Now, to generate code for this, I've also prepared this really small sharplab snippet to look at the generated source code. Now, I generated for 3 cases to see what we want to do in terms of IL generation. And let's look at reference defaults first, actually, which is really simple. If it's a ref type, there is an instruction that basically loads a null value for you. If it's a value type, it actually allocates a local, and it tells the runtime, or I don't know, to initialize it to 0. I suppose this gets expanded when the JIT runs to what this init object actually means. And for generics, it's basically the same thing. It just references the generic parameter here to say what kind of object to initialize here. So what I suggest is that today we go with this generic / value type default. We can later optimize it to just load null for ref types, but the simplest is to just go one way and hope that Ryu is smart enough to optimize this out if needed. So let's see what we have to do. I'm gonna use this session as an excuse to kind of explain in little detail how the parts work that we're touching. So I also have the dev host set up. If you haven't contributed to Draco yet, we have a dev host compiler. This is basically the same as the command line application. It wraps up the compiler, but you can run it straight from the IDE, and you'll have the full BCL configured for you without having to manually inject all metadata references and such that MS-build would do for us. And it points exactly to this source code. So if now I run this, hopefully I'll get the error messages. Yep, the same ones that we get in VS Code. So all good. Apart from the dev host, the compiler core itself lives in Draco.compiler, and we have an API and an internal folder structure. API is pretty self-explanatory. It's basically our interface towards tools like the language server. It's also a public API that people can use to compile code by themselves on the fly. And the internals is basically what we care about today. It's where we implement all the nitty-gritty details of the compiler itself. Now, what we care about today is basically the symbol tree first, as we need to define an intrinsic symbol for the default value. We already have some of these intrinsic symbols. For example, when we import a type like hash code, or let's do some generic list. Let's import the generic collections, and let me get rid of this. Whoops. When I type this, let's make sure to add something to it so it can guess the type. So when I instantiate the list type, it's actually generating an intrinsic method behind the scenes for list, for all of the constructor overloads actually. If I open the parentheses here, you can see it lists out all the overloads for list. And this is an intrinsic method that internally just allocates the object, passes on all the arguments and returns it. So we already have the concept of intrinsics in the compiler. It's not something we have to invent. Let's see if I can uncomment this. Yes, I can. So what are symbols? Symbols are basically mostly named entities in the language. For example, a local variable, a type, a module. It could be a function, a parameter, and so on. Types are also symbols. And yeah, basically that's what types are. And all of these different symbols live in the symbols folder here. And all of the abstract definitions for symbols live in the root. So basically everything derives from the class symbol. This basically defines what every single symbol has to have as a property. And then we have all the more specific ones, like how a field must look, what a field must contain, what a parameter must contain, what a property must have, and so on and so forth. And we also have subfolders for the different sources where symbols can come from. For example, symbols that don't exist or result in a type error. We have these special error symbols, basically placeholders, to stop propagating errors, mainly type errors or not found errors, so you wouldn't get a huge pile of error messages just for missing a single import or something. We also have the generic instances. These are all symbols themselves that basically substitute the generic context for you when you instantiate them. We also have symbols loaded from metadata. These are basically all the references from the base class, or if you include a project or a package from NuGet, it would basically come from metadata, and you would have symbols from here representing all the entities. And of course we have source symbols that come from actual source code that we type out in Draco. The most interesting one for us today is synthesized, which basically means that the compiler generated these one way or another, because it has some inherent knowledge about them. The simplest one would be the primitive, which is just a primitive type definition. We have a few of these. We also have the oddly named intrinsic function symbol. This isn't the symbol type we'll need today. It's basically used for the global initializer for a module as of right now. Let me look for something that I can show you. Yeah, constructor function symbol is what I've been telling you when I talked about lists and how we generate a constructor function for each imported type. And this is basically the intrinsic function that does this for you. For an intrinsic function, you would basically override its name. That's important. The generic parameters, if there is any, its regular parameters, and you would also provide code generation, which in this case is actually quite simple. We just define a register where we're going to write the instantiated type. We would look up the constructor symbol. We would generic instantiate it if needed. This is an edge case for generic types. And we are going to write a new object instruction, basically. We have our own intermediate representation in the compiler. And this is just a factory method imported from this optimizing IR namespace that writes a new object instruction for us. So I would say let's start defining this new intrinsic. So I'm going to call it default value function symbol, maybe, or just default function symbol. I might like default value better. It's a bit more descriptive. And I'm going to cheat because it's been a while since I've worked with our symbol API. So I'm just going to have this on another screen to be able to peek what properties I would likely need to override. Let's seal it. And let's leave some API documentation. Yeah, that's going to be good enough. And we're going to derive from function symbol. And let's see what we need to implement. Only a few things are required. We're going to do a few more. We're going to override its name. It's going to be default. Is special name, I don't remember what that does, to be honest. So we're going to look into what is referencing that. Okay, so for example, we don't provide completion, that's one. And we also have a non-special members for types. Okay, it doesn't look like something relevant to us currently. So I'm just gonna leave it as default, and we're going to change it if needed. So visibility wise, I believe we can make that public by default. And yeah, generic parameter wise, we obviously need one generic parameter because we define this as a generic function, so it's obviously going to need a single generic parameter. So let's do the pattern that we usually do, which is that we define a private method to construct the lazily constructed members, and then we're going to fill them up lazily. Sorry, initialize the fields, the caches basically lazily. Yes, and it's not going to be empty. We're going to return a single thing. I believe we have a synthesized type parameter. I wish VS was more helpful here. Containing symbol has to be this. And the name can be T, that's fine. And we're also going to, yeah, for parameters, empty is fine. And as for generic parameters, we're going to write our little builder pattern in just a second. I'm hoping Copilot will pick up on it. Yes, it will. Yeah, so basically, a really common pattern in the compiler is that we lazily initialize the properties on first access, at least the ones that are costly, obviously returning an empty collection when we know it's just going to reference immutable array.empty is not costly, but the ones that will allocate or something will be lazily initialized, and we make sure that it's well, it's not entirely thread safe, but it's an idempotent operation. This is because the BCL itself is massive, so if the user had to wait for us to discover the whole BCL recursively when they compile something or start Visual Studio Code and want to see autocomplete, they would have to wait for minutes. Okay, as for the return type, it's really simple. We're just going to go generic parameters 0. We might as well leave a signature here. So this would make more sense. Okay, let me peek at the constructor function to see what else we would need to initialize. Okay, code generation we definitely have to override. And let me have it here because that's still a public member. And we can write it as a lambda here. we're going to deal with that in just a second. I believe that's going to be fine, yeah. So, oh god, we have spammers in chat. It would be nice if I knew how to remove them. I'm not going to deal with that right now, unless I can make Kuino an admin quickly, and he would be kind enough to ban them for me. Oh, I can, actually. So, let me continue. For the Codegen delegate, we pass in the function body Codegen type, basically the thing that generates our IR code to for the given method. In this case, we would write how you generate a default value. The target type is the type expected from this code generation. This is passed in because in generic instances, this can differ from what you declare here. And as for arguments, this is the IR operand references to all the arguments that are passed in. This case, it will always be empty because we have no arguments to this method. So for now, what we're going to do is we're going to define an empty register, and without doing anything with it, we're just going to return it, and we'll fill it in as we go. Thank you, Quinox. So we'll need to fill this in later, and let's try to register this symbol so the compiler can actually see it when we start looking up names. I believe we do this in the well-known types class, where we define all the well-known things. Yes, we do. Here we can see all the primitives, the built-ins, like the array, the not operation, all the operators are also defined here. So let's do default value. Actually, we could make it a singleton to make sure that no one reinstantiate this, because for now we don't need to access anything externally. So let me make the constructor of this private, and we provide a singleton instance for it. With this, we should have the type registered, so it would be looked up, but we should crash somewhere, maybe in Codegen, or during runtime, who knows? I'm not entirely sure. Yes, we do crash, that's good. But we went past lookup, so this looks fine in terms of registering this intrinsic. The compiler picked up on it. So to be able to diagnose this a bit further on what we're missing, we obviously know what we're missing, we didn't implement anything, but just to show it off, we can turn on the setting to actually dump the IR code that we're generating for the compiler, and we can do that. I'm going to have to peek because it's been a while since I worked with the CLI as well. Oh, it's simply IR. Wonderful. So we can do this, and we should see the IR code being generated. Yes, obviously the problem is that we have a bunch of registers referenced here that we basically never filled out or did anything with. So what we can do is actually call, let's put a breakpoint here and see in what context we're actually calling this. So the first one that's gonna hit is when we try to create a default of object. So let's see our parameters. We get the Codegen, that's fine. We should see no arguments, that's also correct. And the target type should be object. That's good, that's good. And the next one should be a hash code. Okay, and it should also have no arguments. And this and another Codegen instance should probably be the same one actually. So these both look good. Now we need to just fill this in. Now this is going to be a theme. It's been a while since I worked with our intermediate representation, but I did take a peek before the stream. And we have a constant type that we use to provide constant values. And this is where we translate that constant into IL, basically IL instructions. For example, if it's an integer, we're going to load a constant I4, basically same for bool, but we translate the boolean into a 1 or a 0, and so on and so forth. Rooms, which are characters for us, basically translate to an integer as well. And for strings, it's a bit more complicated. And now one way is to basically shove the default value into this constant type handling. So we could have a special sentinel object that we could shove into value here of the constant type that would basically denote default value. But I'm not really a fan of this because constant is already kind of overloaded and it's known to just do the loading of the literal thing that it was supposed to store. So what I'm thinking is that we would introduce another sort of operand type to denote default value, not within constant, but it would be its separate own thing. So let's do that. If we dislike it later, we can always move it into constant handling. So let's try. We'll call this default value. And it doesn't have to be a class, it can be a read-only record struct actually. And all it has to be is an operand. Operands are basically things in our IL code that can, well, be operands of instructions. And you can see that constant is basically an operand as well. Types can be operands, basically symbols can be operands, and registers can be operands as well. Let's implement the interface. That should be really simple. Actually, before I comment, I'm going to add the type here. Yeah, that should be it. And let's actually try to write the default value now. Yeah, so I believe we need to import the instruction factory as a static. That's also a pattern we do with intrinsics. Almost Copilot. And now we can basically use all this inline. And I believe we have a copy or load or something. Yeah, load, that basically loads a value into a register. That's perfect for us. So what we're going to do is that we're going to load the default value into a register, and we're going to return that. Can Codegen actually return an operand itself? What I'm wondering, to avoid basically a register allocation here. Let's check. It's entirely plausible, yeah. It looks like our compiler doesn't rely on a register here. So we could do that. Yeah, we do the same check here. Yeah, let's actually not define a register then. What we're going to do is we're just going to return the default value for that type. So no fancy code generation today. This is way simpler. And we don't need to import that as well then. And hopefully now we're going to get stuck at translating our IR to MSIL or CIL, whatever it's called now. Oh, we don't go past that, of course. Let me actually go back to running it. Do we have an option to dump the MSIL? I wonder. That would be a really neat feature if we didn't have that in the CLI. It looks like we don't. Okay. So let's try to run it and crash, I suppose. Okay, yeah. The default value is just simply unknown. Let's handle it then. Here we basically need to do what I've shown you at the start of the stream, which is basically allocating a local, loading its address, I believe. I don't know what ldlocK stands for. I believe load address. Oh, yeah, load address of a local variable. And .s, I suppose, signals that it's going to be a short index to not waste any more bytes than needed. Then we need to call init_obj, and then which will obviously pop off the address from the stack. And then to have it on the top of the stack, we're going to call load local. So let's do that actually. Let me copy paste here because today I'm not the fastest. I won't remember it. So we need to allocate a local. How do we do that in the IL? I don't think that we've ever done that from IL directly. We always had a corresponding register in the Codegen for our own representation. But I suppose it's time to come up with some custom way to do it. We have allocated locals, which are separate from the registers because locals will get an entry for the debugger. And we have registers, which are all the locals, intermediate locals that we need to allocate. Now, if I'm not mistaken, we have a single method where we get a register index assigned. Yes, we do. We could somehow call this with a custom register value. Unfortunately, it has an index, which I'm not a fan of in the current situation. Let's think about how we can solve it. Basically, how to allocate a register that definitely won't appear in code in the future. and we can use to default initialize the value, or construct a default initialized value, sorry. We could have the notion of negative indexed registers that are allocated from CIL. I wonder if the index is referenced from anywhere other than to print. Well, equality uses it, and printing. So yeah, that looks fine. Let's do something like so. So we'll know that if it's a negative register, we're going to print it slightly differently to annotate that this is a... Hang on, this will never get printed actually. Yeah, this will never get printed because this is just in the the CIL generation. So yeah, let's not handle this case. We know that we can just have negatively indexed registers for now. So let's see where we fill this up. Here, okay. Let's make something like yeah, we're going to basically construct a register in line that we're going to then pass into this function very lazily. I don't have a better name for this to keep track, so we're going to just go with this one. I know that this method does a bunch of useless lookup that we don't care about. Well, this is not that useless. This is actually a useful check, so this is fine. This is useless for us because this is part of the stackification, something we don't really care about at this point. Maybe we'll have a stream about that, explaining the process of that, but it's really simple what we do in terms of stackification right now. But it basically has to do with the fact that our intermediate representation is for a register machine, and we're translating it to a stack machine. So we try to restore some of the stack machine-like logic to have less useless code generated. And this is utterly useless as well. Starting to think of it, we might not even want to call this at all then. Yeah, let's just do this instead. Whoops. Oh. No, I'm going to still do that because I'm too lazy to duplicate this logic and mess it up by any chance. So I believe we're ready to actually allocate a local for our default value. And since we're declaring stuff here, let's encase it. Yes, this is correct. Oh wait, if it's null, I believe we can just skip it. Okay, Copilot basically wrote this for us. Let's actually hope that it works. I mean, we can run it. There's no harm in that. No, it doesn't like it. Oh, because stackification. Oh no, it tries to get the register index for this, but why? Oh, okay. Let's just really dirtily hack this out. Okay, it ran. So we don't know what that means yet. Let's try to actually log it. Of course, you'll see the tool set freak out still. The language server still doesn't know about this intrinsic. We're going to recompile it in just a bit to have knowledge about it. Okay, it logged nothing. I wonder if there's anything in the BCL that returns null, so I could compare. I could compare it with reference equality. But we'll see how we can do it. Actually, let's cause some null pointer exception. If I can even call toString on it, I'm not sure. Oh yeah, that's a null ref exception. So I believe we successfully constructed a null value. That's awesome, guys. Let's quickly check the IR code. But it should be pretty simple now. Why aren't we... Finally. So as you can see, it's really nothing big in terms of IR. We just have a sentinel value here denoting that this should be a default initialized something. Let's also compile it and check the result in ILSpy. I'm going to open that on another window and drag it in. If only I knew where the binaries are. Let's see if there is a parameter to say that. Oh yeah, of course, that's output. So let's do -o. Okay, it's a bit simpler this way. So let's check out what it's gonna show us if we try to interpret it as C#. I usually check new features like that, and it looks correct. It actually recognized that we have a null literal here, and it also recognized that for hash code we're trying to just construct the default hash code. Now, one other thing I want to check that could be a little flaky, I don't know. If I forward this to another generic method, basically. And use that instead. Let's see what we are doing then. Okay, let's reload. Okay, so we're calling def here, that's fine. That looks correct. ILSpy doesn't seem to yell at us, and the code seems correct as well. So I would say this is a success at this point. Let's do one more thing, is that we should recompile the toolset so the language server won't yell at us. And let's revert this because this is just some stupid test code. And it's actually pretty easy to do that. I need to unfortunately close VS Code, but once it's closed, we have a script that you can just invoke called the install lang server. It will rebuild if needed and install the language server as a .NET tool for you. It was installed successfully, so let's see. It will need a second until the inlay hints pop up. That's when we know that the thing started. And it's successful. Wonderful. Now, you may say that this default generic type thing is cumbersome as hell. And you would be correct, but remember that we have pretty nice type inference. So if I do something like this, if I'm not mistaken, it should be able to infer it without issues. It does, at least it doesn't complain. Maybe in the future we should have inlay hints here, so it would just tell us what the generic was. You know, it's not a feature that many people would want, but for debugging ugly link refactorings and such, when you have 20 methods chained up, all generic, it might be useful to sometimes turn on inlay hints for generic method calls as well. So this might be something for a future stream. Let's see if we can shorthand it. Maybe it will help you visualize better how good our inference is. You don't need to type anything here. And now def is just the same thing. Of course, I could type system.hashcode here as well. So I wouldn't have to type out the generic parameter here either. It would be just inferred. And if all goes well, this should compile. And if you refresh, that's still the same code. And let's look at the C# view. Yeah, that's perfect. I believe that's a feature done, and it took us very, very little code. If we look at the change set, it's basically a new defined intrinsic function symbol, and the Codegen for it is laughably simple. The only tricky thing is that we needed to construct the generic parameters and have the return type be the same thing. This is how the type system can unify that the return type and the generic parameter are the same type, obviously. And then for the Codegen, we just return the Sentinel default value for our IR. For the IR, we introduced the default value Sentinel, and in the CIL, we did a little hack to be able to allocate registers here locally and translate the default Sentinel into the appropriate CIL set of instructions that we discussed at the beginning. Yeah, we also registered the default function intrinsic into the global namespace, so the compiler can look it up. So this is a really small commit. All there is to it now is to write some tests and PR it to the main compiler. Now I'm gonna stay here for a few minutes. If there are any questions regarding the project, the feature we developed, or the compiler in general, I'll be happy to answer it. Just be right back. I grab a glass of water, and if there are no questions, then we can wrap this session up. All right, no questions. Good to hear that all was clear. So thank you everyone for tuning in. I hope you had some enjoyment or some insights to the compiler, and hopefully see you sooner than the last time. Bye, guys.